Hello students, today we are going to see about the logical instructions of ARM7. In the last lecture we have discussed about a few of the instruction sets, namely your data transfer instructions, multiply instructions, and then now we are with logical instructions. And we have also solved some of the problems, small problems, by using Keil software. Today also we will discuss logical instruction of ARM7 and then we will do program in Keil using logical instructions. So there are 4 logical instructions, namely AND, OR, XOR and bit clear in ARM7. So AND, it is represented by an ampersand symbol, and OR, it is represented by a vertical line, straight vertical line, and XOR is a cap, and bit clear you have an ampersand and also tilt symbol is representing your negate. Okay, that I will tell you what is that. Bit clear is the one of the added advantage of your ARM7. So now coming to the logical instructions of ARM7, logical instructions, we will perform bitwise logical operations by using logical instructions that you already know and you are familiar with 8051 logical instructions. So here the general syntax is you have an instruction, namely your opcode here, either it is AND, OR, XOR or BIC. The condition and status update S is optional, so that is why it is represented by the flower bracket, and RD is the destination register, and these two are the source operands, where RN is a register, where this N, it may be immediate value or it may be a register, or you may perform any one of your shift operations. That is your N. So coming to your AND, so you have here your destination register will be having the data from Rn, the source 2 operands, Rn and with N. So result will be saved in Rd. Similarly for your R, Rn or with N, store your result in your Rd. XOR, you know the truth table of XOR, for dissimilar inputs you will be having 1. That is your truth table. So here also 2 source operand, Rn and N, XOR, and the result will be saved in Rd. And one important feature is bit clear. Okay, bit clear, BIC, that is represented by RD, Rn and 1. Okay. So the second operand is N here. Okay, second operand is N here. So each bit of N, if it is 1, after performing this operation, the result corresponding to that bit will be 0. Corresponding to that bit will be 0. I will tell you how. First operand, let it be 1011. Okay. And the N value, let it be 1111. Okay. So you need to do the real operation of the bit clear is Rn and with the negated content of N. Okay. So what is the negate value of all 1? You will be having all 0. And this will be retained as such. This is 1011. What will be the result if you AND? You will be getting 0, 0, 0, 0. This is the result. Am I right? So that is what it is mentioned here. For every bit, whichever bit is 1 in the N operand, that corresponding bit will be cleared in the result. See here, I have taken all 1. So the corresponding bit of the result, the same corresponding bit of the result will be cleared. Okay. Hence it is said to be B, I, C, RD, Rn, N, whose equivalent operation is Rn, okay, and with the negated content of N, store the result in the destination register. Okay. This is your operation of your BIC, bit clear. This is said to be bit clear. Okay, let us come to a small program. So we will evaluate the following expression. So namely X XOR 45. So the X XOR operand, this is your XOR operand, and if we represent like this, it is right shift, logical shift right. If we represent like this, it is logical shift left, and vertical symbol represent your OR, ampersand symbol represents your AND. Okay. So given us this expression, this is the second, this is the first one, and this is the second content. You need to do 1 AND with 2. So first let us look at with 2. What is there in 2? You have y variable and z variable. Y variable you have to shift it by 4 times right, and z variable you need to shift 2 times left, and then the result of those shifted operands should be odd. Only then 2 is done. Only then 2 is done. Okay, and after having 2, okay, and take about your first operand. See here, your x content is XORed with this 45H. Okay, after doing all that, you do the resultant AND, and the resultant content will be saved in W. We will do this program stage by stage. First, let us take the operand x, y, z. So x is taken to be 25, y is taken to be D5, and z is taken to be AD. And the same thing whichever I have discussed in the previous lecture, D is nothing but define constant double word. I am defining x, y, z to be a constant of 0x25, 0xd5 and 0xad. Is that fine? Okay. So then we will go ahead. So x is 25. Okay, x is 25. First get the address of x variable. Get the address of x variable in your R4, and now R4 will act as a base index, and get the value of R0 in your, your x variable in R0. So now what is your R0? R0 is nothing but your x. X is nothing but 0x25. Okay. So now again, what you need to do with the first operand x? You need to AND this with 45. You need to AND this with 45. Sorry, it is XOR. It is not AND, XOR. So XOR this with 45. So 0, 0, 1, 0, 0, 1, 0, 1, 45 is 0, 1, 0, 0, 0, 1, 0, 1. For dissimilar inputs you will be having 1. So this is 1 and this is 1, this is 0, which is nothing but 60. So result is 60. So see here, R0 is already, we have 25. XOR this with 45. Save the same result in your R0. Now here R0 will be having the result. R0 is updated to 60H. Okay. And then come to R4. Come to R4. R4 is equal to Y. Meaning get the address of Y operand in your R4 and move the content of Y in your R1. And what is your Y? Y is given to be D5. Y is given to be D5. So here R1 will be having D5 first, whereas here R0 I missed to write here. R0 is 25. So D5. So after getting your Y, you need to right shift by 4 times. So D5 is nothing but 1101 and 0101. And it's a 32-bit register, I hope you remember. So first set of 8 bits, second set, third set, and this is the fourth set of 8 bits. This and all is represented by bytes, 1, 2, 3. Okay. So now if you right shift it by 4 bits, this will be lost. So 1101 will be coming here, 0000 will be here, and here 10, and here 10, and here 10. It is retained. See, whichever after right shifting, the emptied number of bits. Now 4 number of bits is empty. That will be filled by zeros only. So that is 0, 0, 0, 0, 0, 0 and 0D. So the result is 0D. That will be saved in R1 itself. So take the content of R1, right shift it by 4, logical shift right by 4. Store the content, R1 will be equal to 0D. So next get the content of Z. First get the address of Z in R4 and take the content of Z in R2. So now R2 will be having A, D. Okay, R2 is nothing but A, D. So now this is logical left shift by 2 now. Okay, so what is AD? 1010, and D is nothing but 1101. So if you left shift by 2, so this will go to your most significant nibble, 2 bit. So 0010, 1011 and 01, this empty bits will be filled by 0. So what is this result? This is 2 and this is B and this is 4. Okay. So this will be saved in R2. See, take the content of R2. R2 is nothing but AD. Shift it towards your left. Okay, left shift by 2 times 2 bit position. So now your R2 will be 2B4. 0 to B4. Okay. So the next most significant 2 bytes will be 0000. Okay. So now this is done. So this is also done. This is also done. After doing these two, what you need to do? The shifted operands has to be odd. That is why you have an OR here. So R1 content with R2 content. R1 is 0D, R2 is R2 is 0 to B4. So R1 is 0D, 1101, and so 0000, 0000. I am only writing one word, the least significant word. And then what is your R2? R2 content is 02 B4. 0 2 B is 1011, 4 is 0100. Okay, if you XOR this, okay, OR this, first bit is 0 only, this is 2 only, this is B only, whereas this is 1 OR with 1 is 1, so this becomes 1101. 1101 is D. So now here R3 will be having 0 to B D. Okay, R3 will be having 0 to B D. I have carried the values forward. So R0 is equal to 60, R1 is equal to 0D, R2 is equal to 0 to B4, R3 is equal to 0 to BD, and R5 is equal to 20. Okay. So after performing this, after taking at this, see the right side or the second operation is over. The first operation is also over. Now you need to 1 ANDed with your 2. Okay, 1 ANDed with your 2. See, 1 AND with your 2. 1 AND with your 2. Okay, one result is having in R0. This operation is having in R3. Okay, that is why R0, R3 and the result is stored in R5. Okay, that is how I have written the instruction. So if you perform this AND operation, R3 ANDed with R0, you will be getting 2 0. See, R3 is nothing but 0 0 0 0, 0 0 1 0, and B is nothing but 1 0 1 1 and 1 1 0 1. 60 is 0 1 0 0, sorry 0 1 1 0 and 0 0 0 0. And here you have all zeros, all zeros. Okay, so this will be AND means 0 only. So this is 0, this is 0, 1 1 gives 1, and this will be 0, and this is all 0, which is nothing but 20. That is why I have saved R5 as 20. Okay. After that, result is Y. Store that in your store from your R5 the result 20. Now here R5 becomes 20H. Store that in the address as pointed out by R4. Now your R4 till now it's before the previous slide, your R4 is your read only memory. Now we are pointing read write here. See, I am taking W, define constant double word, initialize that to 0, and after that, see, before taking this, I am defining the RAM memory. So, area my data, read write memory is your RAM memory, where your result will be saved. Okay. So, see here, get your W address, the result address in R4. Now, R4 is having your RAM address. Okay. Store your R5 value, which is 20H in your R4. Then increment by 4 memory location, because each line of memory can store only 8 bits. So, this is 32-bit register. So, after storing R5 in the address pointed out by R4, increment your pointer by 4 and then store all your intermediate results, namely your R1, R2, R3 and R0. Okay. Let us do this program in Keil and Shell. Okay. So, this is the program. See the expression I have given here. Okay. So, the same program I have copied here too. Let me run here and let us check the intermediate results. First, line by line execution. First, your x value is 25, that is saved in R0. After getting the x value, you will be XORing it with 45, the result is 60. See, R0 is updated with 60. Then take your value y. Y is in R1, that is D5. After doing right shift by 4 times, it will be only D. R1 is updated with D. And then your Z value. Z value is AD. Again, you need to left shift by 2. That is nothing but 0, B and 4. Okay. After that, shifted operands 0D and 2B4, you need to, what you need to OR. And then the result is saved in R3. Result is 2BD, that is in R3. So, this 2BD should be ANDed with 60. After ANDing it, you have to have your result R5 to be 20. R5 is 20. Okay. Till now it is all, R4 is having only the read-only memory address till 50. Okay. Now you need to store all the value, the intermediate results in the RAM locations. Okay. Zero x 40000000. This is your RAM memory. Let me add new memory window 2 also I will take. Let it be 20x2c. That is your ROM memory. So memory 2 for me it is ROM, 1 it is RAM. You can simply directly type your number. As like your 8051, no need to give D colon, C colon and all. Simply type your number. So, this results, intermediate results has to be saved in your RAM memory. Let us check. See, first 20 is being saved. The result is being saved. First I am asking you to save R5. Then R0, R1, R2. R0 is 60, 0D, B4. And then that is saved. Okay. So, little Indian format. So, least significant bit byte. Least significant byte is saved first. Okay. 20. Then save your 60. Then save your 0D. So, B4, 02. And then save 2BD, that is BD and 02. Okay. Right. This is regarding your logical instructions. This is regarding your logical instruction. I hope you would have understood the entire sequence of lecture. With this, I'll stop today for logical instructions. Thank you.